Welcome to Demystifying Math. In this lesson, we're going to be discussing parabolas. The geometric definition of a parabola is a set of all points that are equidistant from a directrix and a point that's fixed but not on the directrix, and that point is called the focus. Okay, the directrix is a line. In this case, I have the directrix drawn as a horizontal line. The focus is a point. The distance from the vertex to the focus is equal to the distance from the vertex to the directrix. When we talk about the distance from a point to a line, we're talking about the directed distance, where the line that connects the vertex to the directrix is perpendicular to the directrix itself. So what we're going to do is draw out our parabola by moving point Q along the directrix. Notice that the lengths of R1 and R2 are always identical, exactly the same length. Notice that at point Q, we have a right angle. So we have our directed distance from point P to the directrix, which is R2, and R1 is the distance from the focus to point P. And you can start to see the parabola sketched out. Our vertex is up here where we change direction. On the other side, we can draw the other part of the parabola. So again, when you're looking at the parabola, the vertex is in the center where the focal point and the vertex and the directrix are all lined up. The focal point the distance from the focal point to the vertex is equal to the distance from the vertex to the directrix. So the lengths of R1 and R2 are the same all the time. A parabola has an axis of symmetry, or what we call a line of symmetry, that goes through the focus and the vertex. In this case, we have a vertical line of symmetry. The line of symmetry will always be perpendicular to the directrix. Let's start with a traditional equation for a parabola. You're probably familiar with the equation y equals a times x minus h squared plus k, where h and k represent the vertex of the parabola. What we're going to do is rewrite this equation. So we're going to bring the k over to the other side and divide by a. So we have 1 over a equals y minus k times y minus k equals x minus h squared. We're going to let 1 over a equal 4 times p. So that gives us the equation 4p times y minus k equals x minus h squared. Now remember the original equation that we started with, if a is positive, it would open up, and if a is negative, it would open down. So this new conic form of the equation also represents a parabola that opens up or down. If we wanted a parabola that opens to the left or to the right, all we have to do is switch the positions of x and y. Okay, so your vertex is at hk, p is the distance from the vertex to the focus, and p is positive if it opens up or to the right. P is negative if it opens down or to the left. Okay, so we want to graph this parabola, and it's given to us in conic form. The first thing that we need to look at is where is our vertex. So remember, your vertex is at hk. So in this case, it's going to be at 1, 3. In which direction does the parabola open? Well, since x is squared, it would either have to open up or down. If y was squared, it opened left or right. So in this case, it's going to open up because also the 8, which is the 4p, is positive. We want to find the value of p. Well, 4 times p is equal to the 8, the coefficient of the y value. So that means that p is 2. We want to find the ordered pair that represents the focus. So since we know that our center point is at 1, 3, all we have to do is add the p value to the y value of the vertex, and we're going to get 1, 5. Keep in mind that your focus is always going to be on the inside part of the curve of your graph. And we want to give the equation of the directrix. Well, the directrix is 2 units on the other side of the vertex, so it's going to be at y equals 1. Remember that if you have a parabola that opens up, you have a vertical line of symmetry, which means that you have a horizontal directrix because those two lines are always going to be perpendicular to each other. And then we're going to plot 2 more points, and I found 5, 5 and negative 3, 5. And now we can draw our parabola. Notice that our focal point is at 1, 5, which is inside the curve of the parabola, and our directrix is on the outside of the curve of the parabola. Both are 2 units away from the vertex. Okay, here's our next example. We want to graph y minus 4 all squared equals 4 times x plus 2. In this case, our vertex is negative 2, 4. Remember, your vertex is always been given as an xy ordered pair. What's next to x is going to give us our x coordinate, and what's next to y is going to give us our y coordinate. In this case, the parabola is going to open to the right. This time y is squared, and our 4p is positive. 4p is equal to 4, which is the coefficient of x, so p is 1. Then we want to find our focal point, so we're going to add 1 to our x-coordinate this time, because it opens to the right, and we want to be inside the curve of the parabola. And then our directrix is going to be on the other side of the vertex, so we have it at x equal negative 3. Then I plotted 2 more points, and now we can graph it. Okay, the other thing that we want to talk about with parabolas is the eccentricity of a parabola. The eccentricity is defined as c over a, where c is the distance from the vertex to the focal point, and a is the directed distance from the vertex to the directrix. Since these are always equal for a parabola, the eccentricity of a parabola for all parabolas is 1. Thank you for tuning in to Demystifying Math.